This video is going to cover sections 10.1, which introduces us to radicals. All right, the word square in math, A could be a shape that has all the sides the same. But in algebra, it's saying like squaring a number or meaning an exponent of 2. So if we do 6 squared, that's the same as saying 6 times 6, which gives us 36. Negative 6 squared is the same thing. Negative 6 times negative 6 gives us positive 36. So both positive 6 and negative 6 are square roots of 36. Square roots are things that go in there. The big thing I want to focus on right here is that in parentheses with the negative. Calculators do order of operations. So if you type negative 6 squared in your calculator, it's going to square the 6 and then multiply by -1 or stick the negative on the front. You want to make sure you put negatives in parentheses if you're using the calculator. A lot of people mess up and get things wrong because of that. So parentheses. All right, now we're going to continue. So now that we know this, what are the square roots of 100? Well, we have positive and negative 10. That's where this plus minus comes in. When you see that, a plus over a minus, it either means do both operations or it means we're talking about the positive and the negative version. So that's, if you see that, that's what that means. When you're asked for a principal square root, that's when they're saying, hey, we want the positive principal square root. If I'm just telling you to plug something in the calculator, or if it just, gives you a problem like this, it's typically talking about the principal square root. The only time we're really concerned about that negative is if we're solving equations or talking about graphs, because that's where it matters. So pay attention to that. If it's saying solve for all possible, you want the positive and the negative. Otherwise, the principal's okay. All right, let's get into this. So find the principal square root of 25. Well, square root of 25 is 5. Positive is 5. 0.49. Well, if we ignore the decimal point, the square root of 49 is 7. So if we have 2 decimal places, our square root would be 0.7. Because 0.7 times 0.7 would give us 0.49. When you have a fraction, you are taking the square root of the top and the bottom. So the square root of 4 is 2. The square root of 9 is 3. So we get 2/3. Approximate using the calculator. If it says exact form, you want to keep your radical. If it says approximate or round, then 10th is 1 decimal place. 100th is 2 decimal place. Thousandths is 3 decimal place. The reason I'm pointing this out, I know you've heard it at some point in your life, but when it comes to this test, there's going to be questions that say round to, you'll lose points if you don't round to the right place. So make sure you know those 3. Okay, right here, find root 17 to the nearest thousandth. So in your calculator, in case you don't already know, to type a square root, you're going to hit second, which is that blue button, and then x squared, which is right above the log. So if you hit second x squared and then put 17 in there, it'll give you the answer of 4.1231. That 1 tells us to leave the 3, so 4.123 is that rounded. Now let's look at this one, square root of -4. Depending on the settings in your calculator, you might get something that says 2i, or if your calculator is currently set to real, like if you haven't used it before, you're going to get non-real answer or an error. So it could just say error non-real, could say non-real answer. That is because there's no way to take 2 numbers and multiply them together and get a negative. So there's no real answer. For right now, until we start talking about I, the error or no solution is fine. Once we talk about I, you'll have to start using that. So just keep that in mind. If your calculator says error, leave it at that. I'll show you how to change the setting later. All right, cube root is the same as the square root. You just have a little 3 here. So that means you want to find 3 numbers that multiply together to get it. For example, the cubed root of 8 is 2 because 2 times 2 is 4 times 2 is 8. Cube roots can have a negative. If you do -3 times -3, you get +9. And then if you multiply that by -3, you get -27. So the cubed root of -27 is -3. Cubed root of 1/64, same thing. Cubed root of 1 is 1. Cubed root of 64 is 4. Here, cubed root of d to the 6th. Essentially, we're saying, hey, what can I multiply together 3 times to get 6? So if I did this, d squared times d squared times d squared, we'd get d6. Shut up. So the cubed root would be d squared. Cubed root of 16, there isn't an even one that goes in, so that's one where we would use the calculator. To get cubed root on your calculator, you hit the math button, which is right under the green alpha, and then number 4. Number 4 has that little index of the 3 right there. And then you can type 16 and get that it's about 2.52. So math 4 gives you that number. Now, one thing I want to show you is you're going to get this chart on the note sheet that goes with the test. X4, X5. So 3, 4, 5. So these are our X numbers. And then X squared, like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 3. So this is everything to the 3rd, that purple number to the 3rd. And I'm just going to fill this in really quickly. You're also going to get one as a reference sheet. I'm doing this to show you an easy way to use it that will help you do these roots. 1024 and 3125. All right, I think if I do this, I don't know what I just did. Clip art. At one point there was a way to save that. I can't remember how right now. Well, anyway. So the way we're going to use this is, for example, here we have a 3 right here. So if I go to x to the 3rd and then I find 64, I know the cubed root is 4. So this is going to be your index. Find the colored number, and the purple number is going to be the root. So that might help you in the future. Let me move this. I don't know what I'm doing. I'll leave it over there for now and we'll play with it. Okay. Well, there, that's better. Okay. This is the generic form of a radical. That little number is called the index. That tells you how many of the roots you need. If n is odd, and like 1, 3, 5, 7, all of that, if a is positive, your root is positive. If a is negative, your root is negative, like we saw up here with the root 3. If n is even and a is positive, your root is a plus and a minus, because those evens are going to cancel out. If it's negative, there's no real solution. That's where we got like the -4 that gave us an error. So using these here, I'm going to bring this table over, potentially. I'm going to try real hard. All right, we're going to use this table to answer these questions. All right, so the 4th root of 16. So I find 4 up here, go down to 16. It gives us 2. That's even, so our answer is going to be plus or minus 2. Now, there we go. If I do the next one, 5th root, we find 32, we get 2. Odd tells us if it's negative, our answer is negative. So we should have a -2. Let's look at the next one. Fourth root, 81 would be 3. But because n is even, we have no real solution. That can't be there. So that even n takes away our, I don't know what I did. Takes away our answer. Here, the negative's on the outside. So we're going to find the fourth root of 81. So fourth, 81, 3. And then that negative, now normally we'd say plus or minus 3. If we're looking for our principal square roots, it would be 3, and this negative tells us to put a negative in front. That's just a quick way to use that table, how to take those roots, pay attention to the index and your signs. All right, rewrite in terms of absolute value. We're going to go over this really quick, but it kind of focuses on that square root has a positive and a negative value. The square root also cancels out that squared exponent, so you're left with -3. But the fact that you can get a positive and a negative is you could rewrite whatever's in the square root in absolute value and get the same thing. Now this last one, if I were to factor it, I would get -2 and -2. So it's like saying z minus 2 squared. Now, because I have a squared inside, I can put it in absolute value. Without that squared, the absolute value doesn't really help us. I'm not going to ask you to do that. I just wanted to kind of give you a visual in case you see it while you're reading or any such thing. All right, so now the square root function. F of x equals root x. That function looks like this. That's your graph. So if our domain is all x values, we start at 0. I don't know what I'm doing. All these buttons. We start at 0 and go up forever. So 0 to infinity. And the range is the same thing. That's all the y values. And that starts here and goes up forever. So the range is also 0 to infinity. Evaluate, again, just means to plug that number in. So if we were evaluating f of 1, we would rewrite this equation, but instead of the x, put 1. 2 times 1 is 2. 2 minus 1 is 1. And where we're evaluating, we just care about the principal square root, so the square root of 1 is 1. Let's do the same thing with -2. Well, 2 times -2 is -4. -4 minus 1 is -5. Can't take the square root of a negative, so there's no real answer. All right, let's do those same two numbers over here. F of 1, 4 minus 1 squared. Well, 1 squared is 1. 4 minus 1 is 3. If we were talking about an exact answer, you could leave it as root 3. If you chose to round, it would be about 1.73. And then let's plug -2 in the same thing. This is where that exponent or the parentheses would matter in a calculator. -2 squared is 4, and 4 minus 4 is 0, and the square root of 0 is 0. So that's some quick ways of graphing it, or of evaluating with your square roots and how they work. All right, let's look at this equation. Well, if we compare up here, our f of x is the square root of x to this one right here, f of x is the square root of x minus 1, we notice in the equation, under the radical, there's a -1. On the graph, it's going to look like this. So if we compare those two graphs, what's the difference between this green one and this red one? Well, had I not scribbled past the points that I drew, you would be able to notice that the green one moved right by 1, which means our domain now starts at 1, so it goes from 1 to infinity. It's just showing you that when you change something in the radical, it affects your x value on the graph. If you remember back, the domain, you can't have a negative under your radical. So the domain is when this is greater than or equal to 1. Or 0, sorry. So that, because you can have 0. So you would just take whatever's under the radical and write greater than or equal to 0. Now we're going to solve. So we're going to subtract 4x from both sides. Divide by -2, which flips our inequality sign. So we get x is less than 2. Interval notation means it goes down forever with our bracket because of the equals. This one over here, we would say x plus 1 is greater than or equal to 0. Subtract 1 from both sides. And here, squareds are always positive. When you multiply two things together, you don't get negative. So any number is going to work. It has infinitely many solutions or goes from negative infinity to infinity. All right, let's look at a function and a graph. The function r of x equals 108 times the square root of x gives the total revenue per year in thousands of dollars generated by a small business that has x employees. A graph is shown. So this red line is a graph. Approximate your values for R4, R8, and R12. So that means we go to 4 on the x, go up to the graph, 1, 2, 3, 4, 5. Each hundred's broken into 5, so that's about 20. So that first line would be 220. If I did it again for the 8, go up to the line, it's just above the 300, so maybe like 305. Again, we're just doing approximate values. For the 12, we do the same thing. We're almost at 380, so maybe 375. So using our graph with the scale we can see, we estimated. Now, use the formula. Let's see how close we are. So we're going to take this formula and plug in those numbers. So first is 108 times the square root of 4, which if I put that in the calculator, I would get 216. So we were pretty close, our 220 and our 216. Then if I did 108 times the square root of 8, I get 305.5. Those are really close. And then the last one, 108 times the square root of 12 is 374.1. And those are really close. Here, you may have just rounded and said 380. It wasn't specific as to how close to estimate, so it's just showing you how you can use the graph to approximate even when you're dealing with square roots. Now, this last thing, evaluate r of 12 minus r8 and r8 minus r4 using the formula. So r12, we got 374.1. R8, we got 305.5. And if I subtract those, I get 68.7. Then let's do the other one. R8 was 305.5. I don't think I did that right. 374.1 minus 305.5. 68.6. And then over here, 305.5 minus 216 gives us 305.5 minus 216 is 89.5. So if we're interpreting those answers, this number's bigger, right? Nope, I lied. This number's bigger. From R8 to R4 was bigger than from R12 to R8. So it increased faster at the beginning than it did at the end. So the fewer employees, you increase more. That's one interpretation. It's just anything you can say that explains what you see. That's all interpret means. As long as it makes sense and you can justify your answer, you are not wrong. Cubed root of x. We talked about how with odd indexes, you could get anything. You could get any number, positive or negative. So it makes sense that this graph would go forever in both directions, making the domain negative infinity to infinity. We can plug any number in there. And in turn, the range is also negative infinity to infinity because it would go up and down forever. So evaluating, it's the same thing. You're just going to have a cubed root instead of a squared root. You might know it. You might use the table. You might put it in the calculator. It's completely up to you. So if I did this first one here for f of 1, I would do 1 squared minus 1. 1 squared is 1. 1 minus 0 is 0. and the cubed root of 0 is 0. Let's say I wanted to put in the calculator. I'll do the -3 right in the calculator, if I can get it up. There we go. So remember the cubed is math 4, so I'd hit math, go down to 4. Then instead of x, I'm going to put -3 in parentheses, squared minus 1, and that's going to spit out the answer 2. If you did that by hand,